shiny liquid in a bottle that would have these really weird beading like properties. Like my uncles used to just play with mercury in the basement because, all right, hit me, producer Potts.
There has been so much fear around eating seafood due to mercury. I did hear you recently talk about some new studies around the selenium health benefit. Can you explain what that is and share why this is a fear we can finally all let go?
Yeah, I would love to. This is one of those myths that just keeps going. And really we need to just move on. We need to understand that the science has given us answers, and we can eat our seafood in peace, at least mostly. So it helps to explain first like what mercury does in our bodies and why it is like a legitimate harmful element to be exposed to. So the form of mercury that we worry about is called methyl mercury. So that is an organic form of mercury. It's produced by bacteria when they encounter elemental mercury or like non-organic mercury in their environment. And then methyl mercury like bioaccumulates up the like ecosystem, like up the food chain in especially aquatic ecosystems. That's why we see methyl mercury accumulation, especially in large predators like swordfish and pilot whale and mako shark. So methyl mercury, the way that it harms us if we're exposed to it is that it binds irreversibly to selenium. Now we have 25 to 30 different enzymes in our body that are called selenoenzymes because they have one or more selenium molecules as part of their like molecular structure. So, and it's part of how those enzymes actually do their job. And a bunch of these selenoenzymes hang out, they live in our brains. And what they do in our brains is protect our brains from oxidative damage. So they're really, really important. We're like exposed to oxidants. So like molecules that have an oxygen in them that are highly reactive and can do things like damage proteins and damage DNA. We are exposed to these at all time, and we have a bunch of different antioxidant defenses in our bodies, and selenoenzymes are particularly important antioxidant enzymes in our brains. So the way like mercury poisoning affects us is by we get exposed to the mercury, it binds to the selenium in our selenoenzymes, and then those selenoenzymes can't do their job of protecting the brain from oxidative damage. So that damage builds up over time, and that leads to all of the neurological symptoms that are seen with mercury poisoning. And that's where the term mad as a hatter comes from. So in ye oldie days, hatters used mercury in felt making. So they were exposed to inorganic mercury. So the kind of mercury that has a harder time getting into our bodies and a harder time binding with our selenoproteins, but they were exposed to tons and tons and tons of it. Like there's nobody nowadays who's exposed to like that high level of mercury. It was back when it was like a really cool, like shiny liquid in a bottle that would have these really weird beading like properties. Like my uncles used to just play with mercury in the basement because it was again the olden days.
Oh, goodness.
So it explains no, I'm not gonna say that. So yeah, so like before we really understood the like problems with mercury poisoning, mercury was something that wasn't like it was around and it was used in felt making. So felt hatters eventually would get a little bit mad, right? A little bit they would have like clinical insanity as a result of mercury poisoning building up over years and decades, right? So because they were being exposed to a lot of mercury, but the inorganic form. And there's definitely been cases of mercury poisoning, lots of different case studies showing that that can happen much more quickly with methyl mercury. But here's where the selenium health benefit value comes in. So it just so happens that other than Brazil nuts, seafood are the highest sources of selenium in our diets. So most fish and shellfish have 50-ish% of the daily value of selenium or more, up to close to 100% of the daily value of selenium. So they're great, great sources of selenium. So the methyl mercury that fish is exposed to mostly in the fish will bind to their selenium, right? It will interfere with their selenoproteins and selenoenzymes. So the good news for the fishes, though, they have so much selenium that the amount of mercury that they're typically exposed to is not enough to have them have neurological symptoms. And actually, I don't know if methylmercury poisoning has the same symptomology in fish as it does in mammals. So actually, not even sure if it would look the same. But the cool thing is that their selenium helps to protect them. And more importantly, it protects us. So for the vast majority of seafood, that fish or shellfish has way more selenium than the mercury it's exposed to. So that mercury is mostly already bound to selenium. So if it's already bound, it can't interfere with our selenoenzymes. It's already irreversibly bound. So it's already, that chemical reaction has already happened. And the additional selenium that we're getting from that seafood can help protect us from any mercury that might be in that fish that hasn't actually found a selenium molecule to bind to yet, as well as mercury exposure from other sources, right? Because it is an environmental pollutant. So there is mercury around, right? There's some mercury in city air pollution, for example. There's mercury in compact fluorescent bulbs. So if you break a compact fluorescent light bulb, that would expose you to a little bit of mercury. So having that additional selenium is a really great thing to have in our systems. So almost all seafood have more selenium than mercury exposure. The exceptions being those like top predators from polluted waters that I mentioned at the top of this video. Swordfish, actually, the data is mixed. So swordfish in some studies has higher selenium than mercury, some studies equal amounts, and some studies more mercury than selenium. So it seems to really depend on exactly where the swordfish is fished from. And then like shark, whale, like the really large top predator fish. So those are the ones to limit. So no more than 1 or 2 servings per week, and probably avoid for pregnant people, right? So unfortunately, fetuses are much more sensitive to mercury, so that those would be the types of fish to avoid during pregnancy. All others, like everything else common that you're going to get in the grocery store, tuna has like 20 times more selenium than mercury. Like it is not, it is, even if it's a higher mercury fish, it's got so much selenium that we don't need to worry about that mercury. Salmon is a lower mercury fish and also has way more selenium. So like the common types of fish we're going to get are generally all high selenium health benefit value, which is a measurement of the ratio of selenium to mercury in that fish. And what was really cool is, when I first started talking about the selenium health benefit value, I think in like 2013, there were really only a couple of studies measuring the selenium and mercury in fish. It is now part of biomonitoring studies done in the United States and in Canada. So it's actually being routinely measured now. So there's also a whole pile of different studies because there's just so much data. And the more data we have, the more sure we can be that eating a diet abundant in seafood is perfectly safe from a mercury perspective.
That is so much information and really good to know. So basically, a lot of these myths that we've heard about mercury over the years is now we can just put it to the side because now there's all these new studies that have come out and really shown it's not something we have to worry about. And again, that's why it's good to keep up on the science, be up to date with studies, and not be like stuck in one way of thinking and being open to new information. Because if you're someone that avoided canned tuna for so long, me, because you thought it wasn't good for you, and now you have that back as an affordable, accessible food, yes, that's a win. So I think that's awesome. Where can we learn more about like these common myths and the real truth about them?
I have a whole chapter in my book, Nutrivore, dedicated to busting fear-mongering myths about foods, all with the goal of making us feel comfortable in the actual safety, what the science shows is safe, of more affordable, would be considered a lower quality option. But I even do like nutrient breakdown to show that from a nutrition perspective, most of the time they're no different than the more expensive options. So chapter 10 is entirely about making us feel comfortable choosing affordable nutrient dense foods.
That's so great. Thanks, Dr. Sarah.
Thank you.